structures. A data structure is a way of organizing data in a computer so that it can be used efficiently. Data structures are used to store, organize, and access data in a way that is efficient and organized. There are many different types of data structures, each with its own advantages and disadvantages. Operations of data structure. Create, it results in reserving memory for program elements. Destroy, it destroys memory space allocated for specified data structure. Selection, it deals with accessing a particular data within a data structure. Updation, it updates or modifies the data in the data structure. Searching, it finds the presence of desired data item in the list of data items. Sorting, it is a process of arranging all data items in a data structure in a particular order. Merging, it is a process of combining the data items of two different sorted lists into a single sorted list. Splitting, it is a process of partitioning single list to multiple lists. Traversal, it is a process of visiting each and every node of a list in systematic manner. There are two types of data structure: primitive data structure and non-primitive data structure. In primitive data structure, integer, real, character, boolean are the type of primitive data structure. In non-primitive data structure, there are two types of data structure: is linear and non-linear data structure. In linear data structure, array, stack, linked list, queues are the type of linear. In non-linear data structure, tree and graph are the type of non-linear data structure. Primitive data structures. Primitive data structures are basic structures and are directly operated upon by machine instructions. Integers, floats, character and pointers are examples of primitive data structures. Non-primitive data structure. These are derived from primitive data structures. The non-primitive data structures emphasize on structuring of a group of homogeneous or heterogeneous data items. Linear data structures. A data structure is said to be linear if its elements are connected in linear fashion by means of logically or in sequence memory locations. Examples of linear data structure are stack and queue. Nonlinear data structures. Nonlinear data structures are those data structure in which data items are not arranged in a sequence. Examples of nonlinear data structure are tree and graph. Types of data structures. There are many different types of data structures. Some of the most common are linked lists, trees, stacks, queues, and hash tables. Each of these structures has its own unique characteristics that make it suitable for different types of tasks. Linked lists. Linked lists are a type of data structure that uses pointers to link together elements of a list. They are a popular way to store and organize data. Linked lists are used for searching and sorting data, as well as for creating data structures such as stacks and queues. A simple way to represent a linear list is to expand each node to contain a link or pointer to the next node. This representation is called one-way chain or singly linked linear list. Type of linked list: singly linked list, circular linked list, doubly linked list. Tree. A tree is a type of data structure that is made up of nodes that are connected to each other. A tree is often used to represent hierarchical data, such as the family tree of a family. Trees can also be used for sorting and searching data. Trees can be binary or non-binary. In a binary tree, each node has at most 2 children, while in a non-binary tree, each node can have any number of children. Trees are used in various applications due to their hierarchical nature, and they come in different types, each with its own characteristics. Some common types of trees include binary search tree, BST, B-tree, binary tree, AVL tree. Graph. A graph is a non-linear kind of data structure made up of nodes or vertices and edges. The edges connect any two nodes in the graph, and the nodes are also known as vertices. There are many different types of graphs, such as connected and disconnected graphs, bipartite graphs, weighted graphs, directed and undirected graphs, and simple graphs. Stacks. A linear list which allows insertion and deletion of an element at one end only is called stack. The insertion operation is called as push and deletion operation as pop. The most accessible elements in stack is known as top. The elements can only be removed in the opposite orders from that in which they were added to the stack. Such a linear list is referred to as a LIFO, last in first out, list. Queue. A queue is a type of data structure that is based on the principle of first in first out, FIFO. Queues are used for performing operations such as enqueue and dequeue, where the first element entered is the first one to be removed. Front is the end of queue from that deletion is to be performed. Rear is the end of queue at which new element is to be inserted. Insertion operation is called enqueue and the deletion operation is called dequeue. There are 4 different types of queues: simple queue, circular queue, priority queue, double-ended queue. Hash table. The hash table is an array data structure where data items are stored based on their hash codes. It provides fast access and retrieval of data, making it a valuable data structure for implementing databases, symbol tables, caches, and more. Data structures can be used in programs to store and organize data in an efficient way. For example, an array can be used to store a list of names in a program. A linked list can be used to store a list of tasks in a program. A tree can be used to store a list of files in a program. A stack can be used to store a list of numbers in a program. And a queue can be used to store a list of jobs in a program.